Okay, Assalamualaikum and good day everyone. Okay, so for today we will continue on chapter 3, which is spatial and frequency domain filtering. Okay, so again, this is the basic of image processing technique, where after we have an image here, we will do the image pre-processing, and after that we will do image segmentation. This one is actually segmentation. And after that we will do feature extraction, moving on to classification, and finally the decision making. Alright, so for chapter 3, this is what we will cover: image enhancement, fundamental of spatial filtering, Fourier series, discrete DFT, or we can see discrete Fourier transform. You will find DFT more in the notes. Image enhancement, spatial and frequency domain histogram processing. So what is actually image enhancement? So I will just highlight it here. It is more to highlight interesting detail in an image. Removing noise, making image more visually appealing, more suitable than the original image for a specific application. So this is some of the example after we have done image enhancement. As you can see from the original image, it might looks okay, but then for some study, for example, we want to study the bone back here, we can see that the representation of the bone are not very good. Therefore, we will do some enhancement to the image. Thus, we can see clearly the representation of the bone. Okay. Again, for example, for these images, we can see that the PC board up here in image B, in image A, actually is saturated with noise, and we call this it is salt and pepper noise. And then after some enhancement done, we can observe the image in B, more clear image compared to image A. More example on image enhancement. Okay, so image enhancement approaches fall into two broad categories, which is spatial domain and frequency domain. So as of video for today, we will try to cover spatial domain. Okay, so spatial and frequency domain, there are two broad categories again. Spatial domain is a direct manipulation of the image pixels, while frequency domain it is actually manipulation of Fourier transform or wavelet transform of an image. Meaning, if we have an image here, we all do know that image consists of pixel, right? So for spatial filtering, we will directly work on the pixel here. As of for frequency domain technique, the image here, we will convert it to Fourier transform or DFT. Okay, or maybe, as I said here, wavelet transform, or we can say wavelet transform. Then we will do the process in here. So that is what we call in frequency domain techniques. For gray level image, we have the representation of pixel from 0 to 255. So in total, we have 256 pixel. Alright, and again, 0 represent black, while 255 represent white. Or we can say the image will come from dark to light, darkest to lightest. The representation of the pixel is like that. Okay, for many of the image processing operations in this lecture, gray level are assumed to be given in the range of 0.0 to 1.0. Okay, so this is the histogram analysis. You can read further in your lecture notes. So in histogram, really it represents the distribution of gray level in the image. That's all. Okay, so when you want to do some image processing, one of the ways is for you to study the histogram analysis, the histogram representation of the image, which explain the distribution of gray level in the image. So we can see the gray level representation here, down here. This is a histogram for an unknown image, but we can say that the distribution of the gray level is okay. All right, is okay, and we can say good distribution. Okay, this is an example of a good distribution of gray level represented by a histogram analysis. So as you can see, due to for a good representation like this, we can see that there are no problems with the image. The image is just okay. So for example, okay, for this particular image, if I show you like this, we can see that the image is dark, right? It's dark. Even though by not seeing the original image, we can see that this image has some problems. And then from our view, our observation, we can see that it is dark. When we do the histogram analysis, it is true to what we have observed, that the representation of the gray level represented in the area here, which is closer to 0. Like I said, the representation of the gray level is from 0 to 255, and the one that is closer to 0 is the darkest, and the one that that is closer to 255 is the lightest. Okay, so moving on to this one, again we can see that this image here is a bit lighter compared to the previous image. And yes, when we present it in the histogram analysis, we can see that the representation of the gray level distributed around the end of the histogram here. Okay, and again, as for this one, it is saturated in the middle. Even though it is in the middle, but it's still not good. A good representation of a histogram, it should be represented all distributed along the axis of the gray level. Okay, yes, for example, this image, a good representation of the original image. So that's all for the histogram analysis. So we will continue on our next video. Assalamualaikum.